Hi, Bobcats. By now, you're figuring out that our story of the atom is one that has changed over time. So we're going to just kind of fast forward to where we are today in our story. Our objective is to describe our modern model of the atom in terms of the nucleus, the protons, neutrons, electrons, and the electron cloud. If we fast forward to about the 1940s, there are so many people who have contributed to our idea of what an atom is and how it's built. We've already looked at Thomson, Millikan, Goldstein, Roentgen, Rutherford. There's Moseley and Chadwick, and literally a cast of thousands putting together this modern picture. So our modern view of the atom looks something like this. There is this teeny tiny point at the center of the atom called the nucleus. The nucleus contains protons and neutrons, so two different types of particles there in the nucleus. And then the vast majority of the volume of the atom is made up of the electrons that are continuously moving. So if you were to do a time-lapse photo of those electrons, they would blur, and we call that the cloud. So the spherical volume in which those electrons are moving is referred to as the electron cloud. Keep in mind that this drawing isn't even close to being to scale. If the nucleus was the size of a marble, the electron cloud would be the size of the Astrodome, or even bigger than Bobcat Stadium. If we look a little more closely at these three particles, we discover some interesting things about them. For instance, the protons and neutrons are in the nucleus, the electrons are in the cloud. The mass of the proton and the neutron, the mass of the proton and the neutron are very close to one another, although the neutron weighs ever so slightly more than a proton, and the electron weighs quite a bit less. In fact, that's about 2,000 times less than the mass of a proton. In terms of charges, the proton is a +1, the neutron is neutral or 0, and the electron has a charge of -1. If we're trying to count how many protons or neutrons or electrons a particular particle has or a particular atom has, there are some relationships that help us with that. So for instance, the number of protons and the number of electrons should be equal to each other because that makes the atom electrically neutral. I do need to put the caveat on that, though, that this relationship, that the number of protons and the number of electrons is equal, is true for atoms. In the next chapter, we're going to look at ions, and that relationship will no longer be true for ions, which are charged versions of the atoms. But as long as we're talking about neutral atoms, the number of protons and the number of electrons will be the same. And then the number of neutrons will change depending on which isotope we are looking at. Circling back to our objective, we wanted to describe our modern version of the atom. It has a nucleus that contains protons and neutrons, and then the electrons run around in the electron cloud, which makes up most of the volume of the atom.